Before we start, I would like to talk about the motivations to automate your tasks. So if you are using the HPC cluster system, maybe you would like to repeat your calculations or repeat your analysis, etc. And this can be time-consuming if a lot of manual work is involved. So in order to increase your productivity, you can use Bash, for example, to perform simulation with systematically changed parameters for your calculation, or to extract useful information from your calculation output. Because I studied quantum chemistry, as you can see, here is an example. There are lots of numbers. Yeah, this is not, let's say, nice to see. But you only want to get some important informations. For example, the energy for each iteration, or the compute time with respect to the number of processors, so that you can improve your calculation performance. For example, to use more processors, or maybe to submit more jobs with less processors, and so on. For those information, it would be great to use Bash so that you can be very productive. And Bash is a powerful tool to perform complicated tasks. So it helps you to automate your tasks. And also, if you have multiple smaller tasks, you can combine them to follow your own workflow, so that you can work more productively on the HPC cluster system. So as you can see, I'm using Linux, and Bash is available, let's say, on many operating systems, Mac, Windows. For example, you are using Windows, you can also use Bash on your Windows machine. And also, I'm not sure if you heard of this, those FreeBSD, OpenBSD, Solaris, and so on. And last but not least, if you are using PC2 Jupyter Hub or Jupyter Notebook, you can also launch a terminal to use Bash. So basically, it's everywhere. So I hope I convinced you that Bash is really useful and very widely used. In this part, instead of reading through all the slides, actually I don't have any too many slides here. I would like to give you a crash course with a small case study, so that you are able to use Bash and related tools. For example, grep, SED, AWK. No worry about them. I will clarify everything soon. And then to build your own workflow from one command, for example, command 1, command 2, and so on, to build up your own workflow so that you can work very efficiently on the HPC cluster. And the goal of this course is to get essential knowledge of Bash and the related tools, so that you can work efficiently, instead of to be a true expert. A true expert, this requires much more that is goes beyond all this course. So for this crash course, I will give you some live demos for using Bash, covering those topics: hello world, variables, arithmetic operations, command line argument, conditions, loops, and so on, very quickly with concrete but small examples, so that you can learn it very quickly. And then I'm going to show you a small case study, so that maybe after this, I don't know, maybe 20 minutes live demo, you can apply this technique already to your own workflow. Yes, as I said, my slides is almost done. So live demo, let's go. Yes. For the live demo, you can download all the codes from the link posted by us, by Alex, and also by myself. Go to efficient tools for this course, and then go to live demos, session C, bash crash course. You will see all those example codes. So feel free to join while I'm typing, for example, to look at those codes so that you will have, let's say, a real type feeling about how to use bash for this part. I would like to see it because this is good for live demo. Okay, let's see. Here is my terminal. I think the online participants, you can also see my terminal. On the left side, it's my bash script, which is from our course materials. And on the right side, I'm going to just execute those bash script so that you are able to see the, let's say, output of the bash script immediately. Yeah, as Alex just introduced the Vim, I will try to strengthen your Vim practice right now. So using Vim, you can open the first bash script. So the very first example is always a hello world example. You can use the command echo to print out some string. So the first one is to print out hello world. Or you can use printf. If you have some, let's say, knowledge about C-like programming language, you can also use printf, as you can see highlighted here, to print out the string. But please note, if you are using echo, you will have an implicit new line. You will have an implicit new line. And if you are using printf, there's no new line character. So this is the, let's say, difference. But anyway, you can use printf as well as echo to print it out. And there's no specific requirement. I think this is only a personal preference to do the hello world bash script. The second bash script shows you the variable. So like many other programming language, you can use variables in your bash script. Here, you use a variable for a string with the value of hello. And then you can use this variable in echo or printf by simply prefix a dollar in front of the variable name. And then you are able to print out the value of this variable. And also you can declare a variable or as an array, which contains not only one value, but an array of values. As you can see, it's very simple, just an array variable of strings, like hello world, exclamation, and then you have this variable. The first element is indexed by 0, as you can see here, 0. The second one is 1, and the third one is 2 to access the individual elements. If you want to access all the elements, you can use this special character, this @ so that you will print out all the elements. For the online participants and also you, if you are curious about the output, you can simply execute the second script. As you can see, you will see hello world, right? And also this hello world printed as arrays. So it's very convenient. And yeah, believe it or not, with Bash, you can also do arithmetic operations, in particular integer arithmetic operations. For example, by using XPR expression command, you can calculate 2 plus 2 or 21 divided by 7. And also you can use another syntax, which is, let's say, dollar, and then double parentheses, and then followed by the expressions inside. So you may ask me, what's the use case for this? This is very useful. For example, if you want to have some integers, in your Slurm job script, and then you can use those expressions to do some simple arithmetic calculations. However, those arithmetic calculations are limited to the integer numbers, not for floating point numbers. For example, if you want to calculate 22 divided by 7, let me type it here. Expression 22 divided by 7, you will see that the result is 3, because the result will be truncated. So if you want to do floating point arithmetic operations, you need to pass this expression to a Linux command or a Linux tool called BC as a calculator to calculate the value of 22 divided by 7. So the first command is to set up the, let's say, scale, the number of the floating point numbers, let's say 8. And then the next command is to calculate the division of 22 divided by 7, and then send this to BC. You will see that now this value looks more like a reasonable value. Of course, you can increase this. The benefit of using BC is, for example, you can have very large digits, for example, 800. You will see that you will have a very accurate, but normally this is not needed in practice. So as you can see, it's very powerful using Bash for doing calculations. And the next one is command line arguments. So you may ask me why this is useful. Because, for example, if you create a script and then you would like to make your script very flexible depending on the given arguments, and then you can take advantage of the arguments. For example, to show you some, let's say, conventions to print out those arguments, you can use $@ to print out all the arguments. This @ symbol is like, this array. If you, now you see the powerful of Vim. So this @ means all the elements in the array. And then all the arguments, you can also use @. but by prefix with dollar. Yeah, this means all the arguments. And then the number of the arguments is dollar hash, which is also the number symbol. Means the number of arguments. The script itself is $0, and then $1 means the first argument, the second, and the nice, etc. If you, let's say, if you only give a few arguments, let's say ARG1, ARG2, ARG3, and the nice argument is empty, yeah, because it's not there. So in this way, you can make your bash script more flexible with respect to the command line arguments. And the next one is to have conditions. If you have some knowledge about other programming languages, you may know if conditions. And in bash, you can also use if conditions. For example, here, you have a condition, if condition, and here you need, it makes a decision whether the number of the arguments equals to 3. So this is a little bit, let's say, a little bit unusual. Minus EQ means comparison for integer numbers if this is equal to 3 in bash. Actually, this syntax is influenced by Fortran, if you know Fortran 77, which is 50 years ago. But trust me, this is the correct syntax. You know, in the early days, there was something interesting. But anyway, as you can see, now if there are 3 arguments for your bash script, the arguments will be listed. Otherwise, you will see this warning message. So this is very useful to build, let's say, sorry, ARG1, argument 2, argument 3, to build up very flexible bash script. For example, for this one, 3 arguments, everything okay. 4 arguments, unfortunately, there is a warning message. And if you have some experience with other programming languages, you know there is an important structure called loop. So in bash, you can also use loop. And yes, to repeat, you can use $hash to print the number of the arguments, and $0 for the script itself, and then if condition to have an condition for this. And then if the number of the arguments equals 3, you can start, for example, a for loop to print out all the arguments. Here, just a simple print for loop, and then for, and then here I means, let's say, this is an iterator which will iterate through a sequence from 1 to the number of the arguments. Therefore, this loop will print out argument 1 is the value of argument 1, and then the value of argument 2, and so on. And here is the for loop. And this for loop is starts with an initial value of I, which is 1, and then go through this while loop. Yeah, sorry, maybe I said a for loop. Actually, I wanted to say this is a while loop. From a while loop to take a look if this value is less than or equal to the number of the arguments, and then to print it out, and then to increment the value of I by using integer arithmetic, which we talked about in our, I think, the third the third bash script. But anyway, those two loops, they have the same effect here. And if there are less arguments, let's say, a warning message will be printed out. So you can try argument 1, argument 2, argument 3, argument 4. Right? On the right side, you will see the output of the for loop as well as the while loop. So which loop to use for your work? It's basically your own preference. Yeah, it's based on your own taste, and you can use either of for loop or while loop. There's no, for me, I do not really have a strong preference. So let's move on to next one, functions. So for bash, you can also define a function, which makes your bash script even more powerful and more convenient, because once you have a function here, you can use you can give it different output or different functionalities based on the arguments passed to this function, like the different arguments passed to your bash script. Here, once again, it prints all the arguments of passed to this function, this hello function. And then the number of the arguments is, once again, I repeat myself several times, dollar hash. And then once again, this for loop from our previous script, you will see that the arguments will be printed out here. So to launch this function, very simple, just the name of the function, and then followed by the arguments you want to send. So to do this, you can run 07. As you can see, you will see our favorite hello world again. So if you want to make this script more complicated, you can use, yes, as the previous session from Alex, Y means yank, and then put it here. You have a new, let's say, invocation of your, let's say, the function. You can make it longer or even more complicated, and then to run it, you will see our favorite part. This hello argument 1, argument 1, argument 2, and argument blah blah blah. This print out. This makes your I hope you found it out or noticed this already. This makes your script very powerful, even for your job script to Slurm. So this gives you higher, let's say, productivity. So the next topic is about redirection to standard output and standard error. So normally, you don't want to have your output to the monitor, right? Because the size of your monitor is limited by, I don't know, limited size. So that is why normally you would like to define a file to store the output of your calculation, right? And sometimes you may want to redirect this real output and error files. Or that is why here we talked about std out, so standard output and standard error. But before we talk about standard output and standard error, you can use the redirection operator, which is greater than, to print out, to send the output to a file. This will overwrite the content. If you want to only to append, you can use double greater than, and then this will only append, not overwrite the content. And then to our point, standard output and standard error. So if you are running a calculation, for example, a demo calculation, you would like to split the output to the standard to a file called output file, the error to an error file, and then you can use this. So one, there's nothing means 1 to the output, and 2, which is standard error, to the standard error file. Or maybe you want to combine to redirect standard error to the standard output, which is your monitor, and then the standard output to the file, because you want to monitor the error, possible errors. You can use this one. And last but not least, you can redirect everything. Everything means both output and error to a file. You can use this double greater than, and then to a file, and then standard error to the standard output. As I wrote here, note as a comment, the redirection order is very important, because this determines if you see the error or see the output. But I think it would be great if I'm showing you some demo. Feel free to type with me if you already have your terminal open. So let's say this demo will just print out something to standard output, something to standard error, but without anything, you will see them on your monitor. So if you want to see them if you use the first approach, you will see 2 means standard error, 1 means standard output. So basically, this means error to the output, which is monitor, but the standard output to the output. So you will see that here you see the error to the standard error, but for output you see to the output, right? If you change the order of this, change the order means, as you can see, I'm getting addicted to Vim. If you change the order, let's run it, you'll see nothing, because this means you put standard output to the output, and then standard error to standard output, which is already to this file. So that is why you see nothing, or everything is stored. Yeah, sorry, because I need to clean up this output. Everything is stored in this output, error and output, they are all there. Okay, let's move on very quickly to standard input. It's very, let's say, attractive to have some interactive script, so that the script will work interactively with given, let's say, input numbers. For example, this one will ask a user to provide, for example, 3, 4, and then calculate the value is the sum is 7. But on HPC, normally you submit your job, let's say, as a non-interactive job. So in this case, the standard input will be very useful. There is a typo. I think this is 0. Standard input is 0. And then you can create an input file, right? The first input is 3, the second input is 4, the next input is, I don't know, whatever, but it is unimportant. And then you can run this by reading the input from this input file, and then you will see this, the sum is 7. So this makes your bash script particularly useful for HPC, to create this one as a job script. And then if you want to change your calculation, just change this 3 to, I don't know, some other numbers, and then run this job again, you see a new output. And the last example is piping. So piping, we talked about lots of commands. So if you have a very complicated workflow, you can split your workflow into individual steps and then connect those individual steps by command 1, command 2, and so on, and then through this pipe operator. One example is if you are only interested in the example for the bash function. For example, you want to learn something about bash functions, because here we have lots of scripts. You can find out the script name. If you type LSL, you see quite a lot, right? You see lots of files, which is difficult to find, but you can use grep function, and then you will be able to see the script talking about function immediately. So this is very convenient, even for such a small work. So I hope this is useful for you. And to wrap up, we prepared this bash cheat sheet so that you can practice this very easily, even though I talked about this scripting quite a while. But if you look at those key commands, it fits into one slide. You can print it out, put it somewhere, maybe on your table, and then you can make your work more productive. Next one is a case study. So due to time reasons, I may not dive into this case study quite a lot. But as you can see here, I created an artificial buggy calculation for, let's say, quantum chemistry, and then try to use a regular expression, grep, SED, and AWK to figure out this buggy calculation. Yeah, I would like to skip this live demo because it will take much longer time, and we still have lots of contents. But all the script can be found here, and we have, let's say, self-explained comments. For example, grep energy to get the energy, and if you want to focus the electronic energy, yeah, you can use NIC. You needn't to specify type everything, just type NIC and then space, and then to search the electronic energy and so on and so forth. So basically, I think this is useful. And we also have more details for detailed information, so that feel free to take a look. And Yeah, I think that's from my side. Before we take our break session and also look at the hands-on C, do you have any questions concerning, let's say, what I presented for Bash, especially for those basic, let's say, for these basic commands, because those are the cornerstone for your daily work. If the syntax is unclear, please ask. Yes.
What's the difference between the at symbol and the asterisk?
Your question was, what's the difference between at symbol and what?
The asterisk.
This one.
No, the star symbol.
The star. Okay.
It's not on the sheet, but
Yes, yes, I know what you mean. Yeah, you are welcome to our advanced Linux Toolflow course. The star is a wild card, which is a representation for whatever characters. Yeah, this is very useful. For example, if you want to ls star dot sh, you will only see the sh, so a shell script or bash script, but not those output or whatever. So here this star means it matches whatever characters, but must be ended with .sh. So this is a so-called wild characters. Yeah, not covered here. Yeah, but it's good you asked this. And maybe you'll notice that there are many different strange characters in Bash. Yeah, but yeah, you, I hope this cheat sheet is helpful for memorize. Thanks, Oliver. There is also a question. Do you have any recommendations on how to learn more about piping? Yes, this is a good question. So, yeah, if you want to learn more about piping or some other bash scripting, I would like to recommend you to do more practice. You know, Übung macht Meister. So Übung ist wichtig. So to do more practice. Otherwise, during your daily work, you may try to think about your small tasks or larger tasks as multiple smaller steps, and then you can think about how to solve this small problem, even small problems, by using piping. Yeah, this is what I can say. I'm not sure if Alex has other suggestions other than Übungen.
I mean, it's always a good recommendation to uh, iterate your pipeline. Start with the first command, see the output, and add the second command in your pipeline, and then look at the output um, to not write everything at once and then be confused because there's somewhere a bug, but iteratively add the commands into your pipeline um, so you see immediately what is the current output and what is the next transformation of this output that I want to add to my pipeline. Um,
Okay, if there's no further questions, let's take a break for 10 minutes, or maybe you can also look at the hands-on, and then I will, after we return, let's say 16:25. I will give it 5 minutes to, let's say, talk about the exercises very quickly so that you have more idea about, how to make your daily work more productive for example, data analysis. Yeah. Thanks. Hello, everyone. Slightly delayed, but let's continue with Hanzang. I would like to give you a very brief overview about the Hanzang, and then so that even after the course you can try the Hanzang by yourself. So in this Hanzang, the purpose of this Hanzang is to show you how to use the bash commands to do data analysis of a quantum chemistry calculation so that you get the useful information very quickly. So if you have this file, you will see that this is a very large file, 80 megabytes, etc. And there are many files. If you have no idea about which is the output, for example, if you are new or very new to the application, you can find out which file is the output by search final energy, right? Final energy. This is final energy. And then star, which is exactly your question. So search final energy for everything here. And then you will see that, okay, this seems to be the output file. And then if you use Vim, this output file, you will be surprised. It has 240,000 lines. It's not readable for human. That's why you have to use, for example, commands to extract, for example, information. For example, final single point energy. This is the information you are looking for. Yeah, final. But you need to put double quotes. Okay, now you see there is lots of final single point energy. So basically, as you can see, by using the Linux commands like grep or some other commands, you can easily get important informations like energy changes or gradient or so on that is useful for your own work quickly. Otherwise, to look at the content of this, the real output is really, let's say, time consuming and not useful, because it has 200, as you can see here, 240,000 lines. It's not for human to read. So that is why in this part we talked about how to use those Linux bash scripts and so on to extract those information. If this access is too much, no worries. We created the so-called solutions so that you can take a look the commands used to find out the information. But you may have noticed the solution here provided here is different from what I was typing in my terminal because there's no Unix solution. As long as any of the bash command works for you, I think that's okay. There's no Unix solution for a problem. As long as it works, you are happy, and also I'm happy. So I hope this is useful.